We have a project idea. Well, step one is we need to make a proof of concept or a prototype. So our goal is to get it working, simply. We can optimize later. So how do we actually achieve this? Well, the way I like to go about it is to come up with a block diagram. Now, it doesn't have to be anything fancy, and the details don't even have to be figured out at this stage. This really is just translating thoughts in your head onto paper. I actually like to draw this. So every project needs a few things. So it needs power. This can come from a battery. It could be USB powered or whatever. We also need some kind of I/O, so input output, which could be buttons. We could have some kind of a display, a screen. Wi-Fi, I'll include Wi-Fi in this, or, Bluetooth. And we need some kind of processing. That's going to be our microcontroller. Those really are the basic categories that we need to think about at this stage. So the goal of doing a block diagram is to just figure out kind of what our requirements are. At this stage, we don't really necessarily know or have thought about it too much, but we're just experimenting anyway at this stage. So it doesn't really matter what we decide. We can always change our mind, but we need to start somewhere. So I'll give you the example of the tennis counter that I was working on. This is basically the first block diagram that I started with. So I knew that I wanted it to be battery powered. So we put a little battery symbol in there and ground. But I didn't necessarily know what batteries I wanted it to run off of, just that I wanted it battery powered. Then, okay, well, battery, it's going to need to go through some kind of a DC to DC converter just to regulate the output. What that looks like depends on the actual specifics of the battery. Well, this is going to spit out 3.3 volts is what I decided to go with at the time. And I didn't know what microcontroller, so that needed powering. I knew that I was going to have a bunch of buttons. So there's a switch. There's another switch. So there were a bunch of buttons. And as well, I knew there was some kind of screen. So this is roughly what I started with. Really, there's almost no details here, but it's starting to put things on paper. It's always helpful to have some kind of an LED that you can blink, so put that in the block diagram as well. Really, really high level stuff. How do we actually translate this into a prototype? That really is what we need to achieve, isn't it? So we have to start making decisions, essentially. And like I said, at this stage, it doesn't really matter what decisions we make, but we need to make some decisions. Once we make a decision, then we can figure out afterwards, did it work, didn't it work, what did we like, what didn't we like, and do we want to change that decision? And that's what this prototyping stage is all about. So in terms of the battery, I decided to go with two AA batteries. The voltage that gives out meant that I needed a boost converter. Microcontroller, I decided to use an STM32. Screen, I identified a specific e-ink display that I wanted to test out, and the buttons and the LED is just standard off-the-shelf stuff. So with some of these details put in, we can start building something at this stage. So we have some options, of course. So we can build it on a breadboard. So a breadboard, imagine most of you are familiar, looks kind of like this. This is just an example picture that I found. It's the stuff where you can plug the wires in, pull them out, really easy to reconfigure. So it makes it really good if you're experimenting, and if you change your mind, it's super easy to change things. Personally, I don't love them just because it's very easy to, if you have anything that's a non-trivial breadboard setup, it can get very messy very quickly, but they do have their uses. So in this case, actually, the e-ink display manufacturers produced a development kit, which so I was able to use the dev kit plus the e-ink plus a breadboard. So I had all my buttons on a breadboard, and as well I had a boost converter off the shelf. What's it called? A breakout board. So that's also something that we can use at this stage. So breakout boards. This is it's not going to be available for everything. So if you have a particularly niche IC that you want to test out or something like that, there may not be a breakout board for it. But if it's something straightforward like a DC to DC converter, you know, a USB breakout board, a whatever it might be, it's probably a breakout board for you. If you wanted to make it a little bit more permanent, of course, you could use Perfboard. This is sort of the next tier up from Breadboard. So you've got it working on a breadboard, and you want to make it slightly more permanent. Well, Perfboard is this stuff that you can solder onto and make those connections. And actually, one of my long time ago, I made this project. This is a project that I made on a Perfboard. It's an LED matrix display. This actually plugged into a Raspberry Pi with the GPIO ribbon cable. You can't see the solder side; it's on the other side of the project, or on the other side of the Perfboard. But and it's a little bit messy. But even with Perfboard, you can have projects that last forever, pretty much, if you wanted to. But that kind of leads me to what is actually my preferred option, which is to go straight to the PCB stage. It's a little bit more involved, only because you need to draw up a schematic, you need to lay out the PCB, but that for me is I find it quite therapeutic to lay out PCBs, so I don't mind. Plus, if you find something that doesn't have a pre-existing breakout board, if you have to make your own breakout board anyway, well, at that stage, you might want to consider just jumping straight to the PCB stage. I'll cover that in a future video, but really it's nothing to be scared of. So that's pretty much it for prototyping. So like I said, we're really interested in just getting it working. It doesn't have to be beautiful, doesn't have to be optimized, but what we want to do is validate our project idea, make sure we can get the sort of the business logic part of it working, and then later on we can spend more time improving it.